everyone, our function f of x equals x cubed is defined over an interval 1, 5. So from 1 to 5, we're going to approximate the area by partitioning it into 4 subintervals and also partitioning it into 8 subintervals. So we have 8 and 4. In both cases, we're going to use the left endpoint of each interval. And then also we're going to express it as an integral sign. And I'm also going to evaluate it. All right. Because my class, we've gone over that. So we're going to go ahead and do that as well. So let's get started. I went ahead and graphed it to save some time. I just plugged in 1, 2, 3, 4, and 5 into this function and just estimated it. Now for the first part, we're supposed to partition it into 4 subintervals. So since we have actually 5 endpoints, but we only need 4, we're starting at 1. That means the left. Since 1 just goes up a little bit, this is going to be really hard to do because 1 cubed is just 1. So if you're looking at this, we're starting at 1, which is right about there. So you just go up a little, then go to 2. You go up to 2, then go to 3, go up to 3, then go to 4, then go to 5. And then we stop right there. And then I'll go ahead and draw lines here like that. So there's your the areas that we're going to be looking at, these 4 rectangles. So we're going to add up these all together. Now we have 5 minus 1, which is the distance between the two, is 4, but we want 4 subintervals. So you can see we're going by ones. So when we take our approximate our area, we're going to be doing f of 1 times 1, because that's one piece we're doing. All right, from 1 to 5, we're doing one piece. Then we're going to do f of 2 times 1 plus f of 3 times 1 plus f of 4 times 1. I'll just stick that there. All right. Since we're just multiplying by 1, all we really need to do is just find f of 1, which is 1. 1 times 1 is 1. F of 2 is 8. F of 3 is 27. And f of 4 is 64. So this all equals 100. So that's our approximate area. Okay, now we have to do this with 8 subintervals. So I'm going to copy this page over. It's going to look like I'm erasing the work, but I'm going to duplicate the page. So I just duplicated it. If you need to go back and look at it, and I can erase this. It's still there, but you're going to have to scroll back to see it. So now we have to do 8. So we have 5 minus 1 divided by 8. That's 4/8, which is 1/2. So we're going by halves now. Since we're starting at 1, this is going to be 1.5. Then we have 2.5, 3.5, then 4.5. Now this one's going to be even harder to graph. So if I kind of, let's see if I can erase some of this, especially this part right here. All right. Again, it's a sketch. These kind of get hard to graph. So we're going from 1 to 1.5, then up to 1.2. Then at 2, we go up to 2.5, then up to this point. Then at 3, we go up, go here, go up, go here, up, go to 4.5, then go up to here. So basically, draw these lines down. There's your intervals. Okay. And I have that little bar there, but that's okay. So basically, it looks something like that. And we do the same thing. We're going to approximate our area. We are starting at the left endpoint, so we're starting at 1, and we're going to go to 4.5. We're multiplying this time by 1/2 because we're going by 1/2 to get the approximate area. So this is going to be f of 1 times 1/2 plus f of 3/2 times 1/2 plus f of 2 times 1/2 plus f of 5/2 times 1/2 plus f of 3 times 1/2. I'm not going to put parentheses on everything. Okay, plus f of 7/2 times 1/2 plus f of 4 times 1/2 plus f of 9/2 times 1/2. Since we have 1/2 in each of these terms, I can factor out a 1/2 and then just evaluate, because all of these had 1/2 in them. And it's going to be a little easier if you want to do it that way. So you're going to get 1 plus 27/8 plus 8. So for the 2 plus 125 divided by 8 plus 27 plus 343 divided by 8 plus 64 plus 729 divided by 8. Now, when you distribute that out, you're going to get 1/2 plus 27/16 plus 4 plus 125/16 plus 27/2 plus 343/16. Then we have plus 32. Then we have plus 729 divided by 16. And use a calculator here, or you can get the common denominator of 16, and you will get 253 divided by 2, which is about 126.5 would be the area. So this is actually a more accurate area. Now we want to do is use the integral method. So basically they want you just to write this as an integral. So you write the integral sign, put the smaller number here, larger number here. So that means we're going from 1 to 5. You write down this is called the integrand. That's what we want to take the antiderivative of, and then write dx. Then once we do that, we're going to find our antiderivative is going to be f, and we're going to do f of 5 minus f of 1. So when you take the antiderivative, you're going to get x to the 4th divided by 4. We're going to evaluate this from 1 to 5. So when you do that, you're just going to do f of 5. So that's 5 to the 4th divided by 4 minus 1 to the 4th divided by 4. So this is 625 divided by 4 minus 1/4. And that's going to give you 624 divided by 4. And I'll just make sure I did this right. Yeah, I did it right. So this equals 156. That's your actual area under the curve. And that's it. Thank you. Have a nice day. Bye-bye.